Let's do a brief recap about the last lecture. So we went over integrating factor and how we could solve some problems with integrating factor. Integrating factor is a useful method to solve differential equations from first order, and when they're linear differential equations, we are able to use integrating factor method to solve these differential equations. The first step was to make this equation in standard form where we had 1 as a coefficient for y prime, we had a p of x function in front of y, and we had a q of x function. And using the integrating factor method, we know that integrating factor is going to be e to the power of integral of p of x dx. Then we multiply the integrating factor with both sides of the equation, and then we end up with a product of y times I of x in the derivative parentheses. And this will be ultimately equal to the I of x integrating factor multiplied with q of x, and generating this integral and then dividing everything with I of x would generate us a different solution for this differential equation, and we would have a plus c since this is an indefinite integral. And today we will be working on the plus c that comes with this integral, and we're gonna give some solve some initial value problems, IVPs, so we can find the solution, more specific solutions, more particular solutions for these differential equations. Now here's a very nice example about first order linear differential equations. This is a first order linear differential equation, so we are able to use integrating factor to solve this problem. We are given an initial condition y of 1 equals to 0. What this basically means is that when our input is 1, our output is 0, or in Cartesian coordinates, our point would be 1, 0, as 1 in terms of t and 0 in terms of y. So this basically is a representation of a point in the graph of this function. So if we move on to solving this differential equation, the first thing we want to look at is this differential equation in standard form? And the answer is yes, because the coefficient in front of y prime is 1. So we can just move on to building our differential equation. Our integrating factor I of t is going to be equal to the e to the integral of p of x, p of t, my bad, dt. Well, p of t is going to be 2 because y is being multiplied with 2. So our integrating factor will be e to the 2t is going to be our integrating factor. This is a very useful information because we will be able to multiply both sides with e to the 2t, and then we're gonna solve this differential equation basically. So now let's move on and multiply this with the differential equation. E to the 2t y prime plus 2e to the 2t y equals to t times e to the minus 2t times e to the 2t. Well, e to the minus 2t and e to the 2t will cancel each other out, so we are just left out with t on the right hand side. Well, from the different integrating factor, we know that this is actually the product derivative of e to the 2t multiplied with y. You can confirm this by actually finding the product derivative, but we're not going to go over that since we know that this has to be equal to the product derivative, and then equal to t. And now we can integrate both sides. This must be respect to t. Let's just fix that real quick. So dt. So integrating both sides will ultimately give us integrating the left hand side is gonna cancel the derivative because of the fundamental theorem of calculus. So we're gonna have e to the 2t multiplied with y equals to the integral of t dt. And now we are left out with something like this. Now we can take the integral, and this integral is a very simple integral. It's going to be t squared over 2 plus c. and we're gonna have e to the 2t times y. So the final result of this differential equation will be y equals to t squared over 2e to the 2t plus c over e to the 2t. Well, not to forget, we have our initial condition y1 equals to 0, so that we can write this as y1 equals to 0. So if we move on to this side, this means that wherever we see t, we can plug 1, and wherever we see y, we can plug 0. So we're going to say that 0 equals to 1 over 2e to the 2 plus c over e to the 2. Because 1 is our input and 0 is our output, and y is the output and t is input, basically. So we are able to make this. And now, what do we know about this equation? Well, we have to know that this equation has to be true, and we're trying to solve for c to get the initial condition. So we're going to subtract this from both sides. Negative 1 over 2 e to the 2 equals to c over e to the 2. And we're going to multiply both sides with e to the 2. So we're going to know that negative 1 over 2 is going to be equal to c. And now, finally, we know the differential equation. The solution of this differential equation will be t squared over 2e to the 2t minus 1 over 2 e to the 2t, like basically just like this. Here's another very good example. Please pause the video and try to solve this on your own. Now, this differential equation is also in standard form, so we don't have to make any changes in its appearance. So we have to find what our integrating factor is, and in order to find the integrating factor I of t, we need to find p of t dt, and p of t is basically 2 over t because of it's the coefficient of y. So the integrating factor then will become e to the integral of 2 over t dt. Well, I can move that 2 outside of the integral, so I would have 1 over t dt, and then this would give me e to the 2 ln of t. And now that this is the integrating factor, well, before we move on, I want to show you something. We can actually make this more simpler, because using algebra we can show that this is equal to e to the power of ln of t squared. Guys, do not try to cancel these guys and write 2t. It's not equal to 2t, okay? This is not 2t. So you're gonna have to write it like this, and once e and ln are in order, basically, now you can cancel them, and then you can say that this is equal to t squared, which is I of t. Since I have my t squared, now it's a good time to use it to multiply both sides of the differential equation. So t squared y, and I know that this has to hold, so the derivative of this product will be equal to cosine of t squared and 1 over t squared are basically going to cancel each other out, so I didn't write them. So now we can integrate both sides to find y. Integrating the left hand side will just cancel the derivative, so t squared y equals to integral of cosine t dt, and the integral of cosine is just sine t plus c equals to t squared y. Now, dividing everything with t squared will give us the solution. This is the general solution of this differential equation. Dividing everything with t squared. Alright, awesome. Now our goal is to use initial condition to solve for c, and now we would have a particular solution. Well, now let's try it. When we have pi for t, we would have 0 for y, so 0 equals to sine of pi over pi squared plus c over pi squared. Well, Sine of pi is 0, so 0, and 0 plus what is 0? Basically 0, so c has to be 0 as well. So we know that c is 0, and since c is 0, the differential equation is sine of t over t squared. Just like this. Let's move on to a very nice example. Well, this is also in standard form, so we don't have to worry about the appearance again. And now what we want to do is find the integrating factor. Let's find the integrating factor. So now we need the p of t term. So the p of t term is going to be the coefficient of y. Don't say the coefficient is 1, because it's not. The coefficient is negative 1. Always treat these minuses as negative symbols. The negative 1, like, think this like this. Okay, guys? So if you think it like that, you're gonna know that the coefficient is negative 1. So p of t equals to negative 1. Now that we know this, we can find the integrating factor, e to the integral, negative integral of 1 dt. I just pulled out the negative 1 outside the integrand. And now we have e to the minus t, and that's your integrating factor. Okay, we can now multiply both sides with the integrating factor. I know the left-hand side will be this product derivative, y times e to the minus t, equals to 2t e to the 2t times e to the minus t. Well, e to the 2t times e to the minus t is just e to the t, because when you're multiplying exponentials, you add the exponents together, so we will have something like this. Now you can integrate both sides to solve the equation. Integrating the left-hand side will just give you y e to the minus t equals to the integral. I'm going to pull out this 2 out, t e to the t. You can pull out the constants out of the integrand, dt. Awesome. Now that we have this, well, this is a very common integral we're going to see a lot in differential equations. We can just use the DI method to solve this. The DI method is a way of solving integration by parts. So we're gonna integrate this part, e to the t integrates as e to the t, and this is plus minus plus. This is a very nice trick, but you're free to use uv substitutions, udv, and you can solve it with that. And now you're gonna get t e to the t minus e to the t for the results of this integral, and you're gonna be multiplying this with 2. So this will be your integral, the solution of your integral, plus c. I didn't multiply c with 2 because you don't need to, because c is always a constant, and another constant times another constant will be a constant, so you can just leave it as is. And now we're gonna know that y e to the minus t equals to 2t e to the t minus e to the t plus c. Well, divide everything by e to the minus t, and you're gonna actually add e to the t for every e to the t, because you're dividing with that. It's basic algebra, so you're gonna have 2t e to the 2t minus e to the 2t plus c e to the t. And now this is your differential equation. I'm just gonna go ahead and see what the initial condition was. The initial condition is y of 0 equals to 1. Y of 0 equals to 1. Okay, y of 0 equals to 1, so every t is going to be 0 and every y is going to be 1. So 1 equals to 2 times 0 times e to the 2 times 0, 0 minus e to the 2 times 0 plus c times e to the 0. Well, this is just 0. This is minus 1. And this is plus c equals to 1. So c is 2 from this equation. So now that we know c, we can just plug c in this differential equation and find the particular solution. Y equals to 2t e to the 2t minus e to the 2t plus 2e to the t. And this is the solution of your differential equation.